All right. I think we can begin. Okay. So I once again welcome you to this session of mathematics under the topic matrix, and we are going to be introduced to this topic. And by names of Kaimba Bosco. Yes, that is my pic down there, in case you're interested in knowing me. All right, let's begin our presentation right away. Yeah, so when we talk of a matrix in singular it is a matrix, and in plural are matrices. So simply we can define a matrix as an array of members, rather numbers, e.g. we have 1, 3, -7, 4, 0, and 5. Then they are saying down here, on a simple level, a matrix is simply a way to organize values into rows and columns. So when they are talking of rows, they simply mean these values here, and columns are these ones, moving from north to south, and the other ones, they are rows moving from west to east. All right, I think we can continue. Yes, now they are saying here, for the purpose of IGCSE further math, you should understand matrices as a way to transform points. So in other words, they are saying that matrices are applied in real life. So here they are giving matrices are particularly useful in 3D graphics, as matrices can be used to carry out rotations, enlargement, and useful for changing camera edges, as we shall see. So here you're seeing a camera behind the screen, and you're seeing how it enlarges these boxes. Right, let's continue. So matrix fundamentals: understanding the dimensions of matrix and operations on matrices such as addition, scalar multiplication, and matrix multiplication. So scalar multiplication, they simply mean any number, which is of course a real number, is a scalar. It can be multiplied by any matrix, as we've seen in our previous slide. A matrix can easily be multiplied by a number. And also matrix multiplication simply means that a matrix can be easily be multiplied by a fellow matrix. Then addition of a matrix simply means we can add a matrix plus a matrix. Okay, then we still continue with our matrix fundamentals. Then we are here, dimensions of matrices. The dimension of a matrix is its size. Okay, how big it is. So that is the dimension of a matrix. So in terms of numbers of rows and columns. So here they are saying that to get the dimension of a matrix, in this first example here, to get the dimension of this matrix, we got a row times its column. Okay, it has how many number of rows? It has 1 and 2. So those are how many rows? They are 2. Okay, and how many columns? 1, 2, 3. So when you get 2 times 3, you get the dimension of this matrix. Okay, yes, I think the same thing was applied here. Okay, here. So when we want to get the dimension of this, you can work it out and tell me the answer, and get the answer. You can pause this video, you work it out, and then you check the answer. So I worked it out, and this is what I got as my answer. I got my answer as 3 times 1. 3 is the number of rows, and what? And 1 is the number of column. Okay, you can see here. How many rows? We have 1, 2, and 3. then column is only 1. Okay, so let's continue. The same thing we shall apply also here. It will be 1 by 3, meaning that we are having 1 row and 3 column. Let's continue. Then notation names for matrix. Notation or names for matrix. So a matrix can be a square or a curved bracket. So we can write it in this format and this format. Okay, this one is a column matrix. This one is a column matrix. Okay, then this one is just a matrix, and then this one is a row. This one is a row. Sorry. This one is a matrix. Then this one is a column vector, and then this one is a row vector. So why are you calling it a row vector? It has 1 row, and this one is called a column vector because it has 1 column. Meaning that our matrix here, this one, is composed of vectors, both row vectors and column vectors. So this matrix has 3 column vectors and 2 row vectors. Okay, this one. Okay. Okay, let's continue. So here they are saying that so a matrix with 1 column is simply a vector in a usual sense. Then they are saying variable of matrix. So if you wish a variable to represent a matrix, then that variable should be a capital letter and it should be bold. Like here I have my A, this one is bold, and this is bold, it representing a vector. There's an operation which was made on these vectors to come up with vector C. Alright, let's continue. Then addition and subtraction of matrix. So simply addition, subtraction, simply addition and subtraction matrix corresponding to elements of each matrix. They must be of the same dimension. Is it clear? Meaning that whenever you are going to add or subtract vectors, they should have the same dimension, mean that they should have the same rows and column as you are seeing in this example. Okay, so the answer here is this and the answer here is that. So let's continue. Then scalar multiplication, this is what I was talking about. Okay, so this is our scalar, it's being multiplied by this vector. The answer is there, they have got it. Then also here, if our A is this vector, then a scalar times that vector, still we shall get the answer, which I'll review to you very soon. Then here we are having a column vector plus k, then this column vector. Okay, here, then they have the answer here. So let's check the answer and see. Our answer is here, our answer is here, our answer is here. So you can go and try it out. Okay, let's begin. Let's continue. Then multiplication of vectors, this one you can work out, right? Yeah, you can work it out. Okay, so it says that when we are multiplying vectors, okay, we should multiply, we should get row times column. Okay, row times column. Okay, so when I multiply this times this, I got these answers, I got the answers, I got my answer. Okay, I got, now I repeat for this times this. Okay, I got this and that and this and that, like that. It's okay. Then this was a paper for UNEB. This was a question from UNEB June 2021. So A matrix equals to 2 0 1 3. Okay, then and B is this. Work out matrix AB, meaning that you should multiply A times B. Don't begin by B times A, because once you begin by B times A, you'll complicate your life and things will be hard for you. Okay, so you should begin by A times B. Okay, matrix are not commutative, meaning that they cannot interchange them. You can't, if they say begin with A, B should begin with A, don't begin with B. Am I clear on that? Thank you. That okay. So that's the answer you should get in case you work it out. Okay. And then now you have a goal. These are the things you can work out simply. I know you guys, you can get these things. Okay, it's the answer AB. Then you get this times this, you get that. Then this times this. Of course, when it is squared, you multiply it 2 times, right? Then power k, still you get the answer, right? Can you get the answer? I think you can get the answer. This answer is this. So 1 power k is okay, and then what? So this is the formula, the general formula. Okay, then we have this one, this times this times this, of course, row times column, then column, and this is what I was talking about. So I'm going to put my emphasis here. This is what I wanted. So here you see they have begun with a row vector times a column vector to get this matrix. But now when you begin by this, you see they are the same. When you begin by this times this, you'll get a different answer. Have you seen that? So that's what I was emphasizing. Okay, so be careful when you're given such things. Okay, so now let I be, this is the identity matrix. What is an identity? An identity is a number in that set. When you multiply, all elements in that set should get the same number. So an identity has no effect on a number. So suppose this is my A, determine AI. What will be my AI, guys? What will be my AI? You see, it will not change. Are you seeing? How about down here? Still the same. So that is called identity. So identity is equal to 1001 is known as the identity, and it does not change. It is fundamental. Okay, let's continue. I'm about to summarize this. So this is exercise. You can work it out in your free time, and answers are there. I can show you the answers. This is my answers, or the one I've got. You can also work it out and compare with mine. Okay, so for this I won't open for you. You'll have to work it out and get the answers. All right, of course this is also an exercise for you to try out. Then other multiplication questions are here. This was the paper whereby you have to multiply this times this, meaning that you are going to generate equations and you'll have to solve them. Let me see how I've done it. Let me see. Okay, I've multiplied the row by column as I was telling you, x squared. So I generated these simultaneous equations. I seeing them, x equals to this and y equals this, and finally I got my values of x and y. Okay, so matrices can be used to get the to find the unknown figures, like we've seen in this example. Row by column, multiply row by column, then equate to the corresponding value, like the way they have done here. They have multiplied this times this, and then they equate it to 4x. Then this is a workout example. Of course, I know you want to see the answer. The answer I will get will be this. Are still the same thing. They are looking for unknowns. Okay, let's begin. I'm about to summarize this. Yes, this is my exercise. I want you students to do this. Came in 2013 in paper 2. Also this came in paper 2 2000. Okay, 16. So try them out. Okay, and this is the answer you'll get. Okay, you get this answer, you get that answer, you get that big answer, and these answers, right? So try them out. You will find them easily for you to calculate. Okay, Okay, so now we go to matrix representing transformation. How does matrices represent transformation? So matrices can represent transformations to points in 2D and 3D. So let's repeat. So I'm going to introduce this one for some few seconds, then we shall come back like after 1 hour, then we go through it. Okay, after 1 hour, that is lunchtime, then after lunch we shall have to come back here, yes, and we go through this. So let us represent a point as a vector. Are you seeing this point? It is here. Okay, we can multiply it by this matrix, okay, to have 2x. When you multiply, you follow our rules though by column, you get this. So what has this matrix done to this vector? If our vector was here, are you seeing this point here? This is our initial point. What has it done to it? Let's check and see. This vector, okay, this is what it has done. That's what it has done. Okay, this is what it has done. It has increased, okay, it has enlarged our vector by 2. So it's an enlargement by a scale factor 2 about the origin. Are you seeing? It was initially here, and now it is here. Okay, so this matrix is increasing is enlarging our points or our vector by a scale factor of 2 about the point. Okay, so it's a transformation. Then these are the steps on how to find to find the effects of a matrix on a vector. So now we need to find the effect on the point. After getting that effect, you draw the old and the new points. So what was the old point? Then from there you can simply determine whether it is a rotation, whether it is a transformation, or it is a diffraction. Okay, so we shall see the rest in our next presentation. Thank you.